All right, first we're going to welcome Xiao Zhang, a PhD candidate in the Academy of Art and Design at Tsinghua University. He will introduce his work on topology reconstruction of a discontinuous B-wrap geometry by using form-founding method.
Yeah, hello everyone. I'm Xiao from Tsinghua University, and now I'm going to share my screen. Okay. Wait, okay. May I share my screen now? Okay.
Yes, you can share the screen.
Okay. Yeah. Let me start it. Yeah. Okay. Wait a minute, please. I'm going to share it. Okay. Hello everyone. I'm Xiao Zhang from Tsinghua University, and today I'd like to share the topology reconstruction of a discontinuous B-rep geometry by using a form finding method. Yeah, let's see it. Firstly, why shall we transfer a non-continuous B-rep to a continuous mesh? For example, in a traditional sports design company, shoe designs will draw sketches and let mold factories to make a sole mold. Since the factory always use Rhino to make a 3D model, the shoe model will be a boundary representation model, a so-called B-rep model, like what is shown in Figure 1. And since the ability limitation of most model engineers in the practice, the model is often not continuous or not even closed. And when the research department of the sports company want to do some finite element analysis, they have to transfer the B-rep model into a functional representation one, so-called F-rep or mesh, like Figure 2. So the research team can know some information like whether the attraction of the pattern is good, like shown in Figure 3. So we need some tools to do the transfer work. And nowadays, parametric designers also need a mesh as a foundation to create their pattern, like what is shown in Figure 4. Yeah. Nowadays, there are many plugins in Grasshopper to help the transition work. However, many of them can just solve fine B-reps, which means they should be closed and the UV texture should be well joined and continuous. Uh, However, it is almost impossible to achieve in a shoe model work in reality, yes, nowadays. So, we need to develop a method by ourselves to make a non-continuous B-rep into a well-continuous mesh, which means every face of the mesh should have a similar area to the neighbor one, just as shown in the figure 2, yeah. Okay. And with the help of the form finding design method introduced by FreeAuto, we can use physical force model to get the shape we want, just as shown in the figure 1. And in 2012, Daniel Parker created Kangaroo 3D in Rhino and in Grasshopper. It is a live physics engine for interactive simulation, form finding, optimization, and constantization and code. If it is see it random Johnny mesh, and on the fourth we will write the instruction. Here is get the B mesh function of to join onto it, but here it has a three edge join point, and here it has a five edge join point. So that means a singular point. And in the figure 1, it is using our method. You can see the singular points, they have a really good distribution. It is controllable. But however, if we use QuadRemesh, some tools like in the Rhino 7, it is almost not that controllable. Some parts, they may have too many these kind of points. So if we use our method, we will have a better distribution of it. And the second one is the mesh gradient advantage. Let's see this figure 3 on the right top corner. It is a parameter which can test if every face the face and its adjacent face have a almost similar area. We can see it is the number. It is a number that every face and the relationship of every face and its adjacent faces, and it is a parameter to judge on it. And we can see if we use our method, it is shown on the figure 2. We will have a really low number, but if we use QuadRemesh method inputted in the Rhino 7, the number is much bigger, which means the mesh gradient, they have a really big difference, I think. Yeah, so here is the conclusion. And with the topology reconstruction informed finding method, we introduce a method to make a non-continuous BREP to a continuous mesh, and it can really helps the finite element analysis for the engineering team, and it also have a bridge to join the parametric designers to code patterns onto a traditional shoe design work. So it is a digital chain or a bridge and joining the research team and the design team, and it is super useful and tested in nowadays in the shoe design work. Yes, and finally, I would like to thank Professor Qiu Song and Yuan Chao and everyone in B439 Studio. And this research is funded by National Social Science Fund of China. Here is the reference, and this is the end of my presentation. And thank you, everyone. Thank you.
Thank you for your great presentations. I have some questions. My first question is to ask Zhang Xiao, could you please share your screen?
Okay, yes, I will share my
Turn
screen.
to your the follow chart page. Thank you.
Okay, so
page 7.
Page 7. Okay.
Yeah. Okay. So your work is related to the topological structure. First, I have some questions. First question is, you just mentioned plane-like and sphere-like geometry, but
Yeah.
for example, if I have a free FREP model with maybe one hole or two holes, just like can you see that? Can you see the screen?
Yes.
Can you see the screen? Yeah. If I have a model, it looks like number 8. How can I build the? If I use the bounding box, I think the model would be wrong. Your result would be
I know what you mean. I think if we have a shape like number 8, if it has two holes, maybe at first it is still we will classify it into a closed BREP, and then we would try to build the low poly the low poly model into this kind of shape. But maybe it is it will be not classified into a open BREP. It would be classified into a closed BREP, maybe. Yes.
Okay, so your work is just to interactively model a low poly mesh first, and then convert it into fine QuadRemesh.
Yes.
However, if I have a model with a lot of hosts, for example, if I have 30 hosts, how can I do this interactively?
It is maybe it is the limitation of my method. It may have too many manual works. It would be research in the future maybe for me. It is although still a very big question for me. Yes. When there are too many hosts, and or even maybe some shape two faces are getting really close, it will also have this kind of problems, because if I use a mesh force, maybe the target BREP and my mesh it will have some cross. Maybe this face will be targeted onto the next by surface. It will be also have some this kind of problems. It will be researched in the future, I think. Yes.
Okay, I hope you can develop this in your future work. And another question is, if I have two tetrahedra, just like this.
Okay. Sorry. I cannot see.
Can you see that?
No. Now, are you?
If I have two tetrahedra, they intersect each other with a point, with a common point.
Okay.
In this case, this model is a non-manifold finite element model. That is very popular in topology optimization results. So how can you deal with such type of models?
Yes. I have a question. It is since my method, it is based on some real project. In the real project, there are not really lots of models. They are joined at just one point. At this kind of situation, we will just make it into two models, and to solve the point of each one of them, and then maybe we will rejoin it in one point at the end. I don't know whether this kind of method works. I don't know, in the topology optimization work. I don't know.
Yeah, you are right. In most cases, we use 3D scanning models. That means that is two manifold surface or meshes, and there's no common points. But in 3D topology optimization, it is possible. And now I understand this is a limitation for your research.
Yeah.
Thank you for your answer. And I have another question to ask Guanqi Zhu. Could you please share your screen? Maybe page 25. Thank you.
Thank you, Albert. Okay.